Hello, my dear students. Today we are going to continue our discussion on chapter 5. We are going to discuss the second period. We are going to discuss the alkenes and the nomenclature of alkene and the structure formula of each one, and we are going to discuss the methane as example for alkene and its preparation and its chemical properties. So let us start. Saturated hydrocarbon compounds that we call alkenes. Alkanes are hydrocarbons having general molecular formula CnH2n plus 2. So we have give reason in this point. Alkanes are saturated hydrocarbons. The reason for that because all their bonds are sigma bonds and have no pi bonds. The first member of alkane family, as shown on the screen, the name and the structure formula and the molecular formula. Methane, CH4, and CH4 also the molecular formula. Ethane, CH3, CH3, and molecular formula C2H6. Propane, the structure formula CH3, CH2, CH3, and molecular formula C3H8. Butane, structure formula CH3, CH2O2, CH3, and molecular formula C4H10. Now we are going to discuss the nomenclature of alkene. The name of alkene is determined according to the longest continuous chain and on the number of its carbon atoms. As shown on the screen, its root name is pentane, and another example, its root name is hexane, and the carbon atoms are given numbers in the longest chain. So if the longest chain here free from any branches or side chain, the carbon atoms are given numbers from any side, left or right side, as shown on the screen. So it's called normal butane. Another example, it will be normal pentane. Here, if the longest alkane chain attached to an alkyl group or any other atoms in the alkane chain begins from the side that which is nearer to the branch, or the nomenclature here begin the number of carbon atom from which the chain arises, then name the branch and ending by the name of alkene, such as shown on the screen. Here its name is 2-methyl-pentane. We have to start the numbering from the carbon near to the branch. And here another example, 3-methyl-hexane. If the side group is repeated in the alkane chain, we use the prefix di or tri or tetra to indicate the number of repetition. Here, as shown on the screen, it will be 2,3-dimethylpentane, and another example, it will be 3,3-dimethylpentane. If the branch is a group such as chlorine, bromine, nitro group, the name of this group is ended by the letter O. So we say chloro-bromo-nitro. As shown on the screen, it will be 2-bromobutane. Another example, its name will be 2,3-dichlorobutane. If the side groups are different, alkyl group and halogen, the groups are arranged according to their alphabetical Latin name, after numbering from the end that giving the branches of the least possible summation. For example, as shown on the screen, here 2-bromo-3-methylbutane. Another example here, it will be 2-bromo-3-chlorobutane. Another example here, it will be 3-ethyl-2-methylpentane. Another example, it will be 2-bromo-3-ethylpentane. And another example here, it will be 2-bromo-2-chloro-1,1,1-trifluoroethane. Now my dear student, we are going to discuss methane. It represents 90% of natural gas under the Earth's crust or accompanied to petroleum. Here, methane gas is called the gas of swamps, and we have give reason for this point. Because it goes out as bubbles in swamps produced from decaying of organic wastes by bacteria. So, methane gas is found in atmosphere in a small ratio 0.00022%. How can we prepare methane gas in lab? Here, by dry distillation for anhydrous sodium acetate with soda lime giving methane gas. Here, my dear student, the soda lime is a mixture of caustic soda, which is sodium hydroxide, and the quicklime, which is calcium oxide. As shown in the screen here, if you heat anhydrous sodium acetate and soda lime, it gives the methane gas that collected above the water, as the following animation show. Dear student, as shown on the screen here, we find that we use mixture of the soda lime and anhydrous sodium acetate. Here we find that the methane gas is produced and collected above water as it is insoluble in water. So, my dear student, as the equation proceeds on the screen, anhydrous sodium acetate plus sodium hydroxide in the presence of calcium oxide that we call soda lime, and by heating gives the methane and the sodium carbonate is produced. So we have give reason in this point. Using soda lime is better than caustic soda in preparation of methane. The reason for that because calcium oxide reduces the melting point of the mixture and absorb water vapor. Another give reason here, my dear student, methane gas collected by downward displacement of water. The reason for that because methane gas is lighter than water and insoluble in water. Now we are going to discuss the physical properties of alkene. The first four compounds are gases such as C1 till C4 carbon atoms, and methane is a fuel for houses, and propane and butane compressed in cylinders used as fuel in houses called butagaz. And my dear student, notice that in cold places propane ratio increases than butane, and in hot places butane ratio increases than propane. My dear students, alkane contain 5 carbon atoms till 17 carbon atoms are liquids of low boiling point as kerosene as fuel. And alkane contain more than 17 carbon atoms are solid as paraffin wax. My dear student, alkanes insoluble in water, and we have give reason for this point. The reason for that because alkanes are nonpolar compounds, so can dissolve in polar solvent as water. Here another give reason, my dear student, metals are covered by heavy alkanes such as paraffin wax or kerosene. The reason for that because they insoluble in water, so protect the metals from oxidation and rust. Now we are going to discuss the chemical properties of alkenes. We have give reason in this point. Alkanes are chemically inactive, don't react with sodium or oxidizing agent. As shown here in the animation, if we bring the methane gas, and here we are going to put some drops of potassium permanganate, we find that the reaction here doesn't occur by oxidation of the methane gas, as the potassium permanganate inactive here for the reaction. So alkanes are not going the oxidation reaction of potassium permanganate. So my dear student, alkanes are chemically inactive and don't react with sodium or oxidizing agent because they have all sigma bond, which is strong and difficult to be broken. Now we are going to discuss burning or combustion with oxygen. Alkanes burns in oxygen and giving water vapor and carbon dioxide, releasing large heat, as the following animation show. Here, my dear student, we are going to prepare methane gas first, and then we are going to burn it. Here we will find that the reaction of burning happens and the carbon dioxide gas is produced and water vapor is also produced. My dear student, these reactions are highly exothermic and used as fuel. As shown in the screen, now the equation of burning of methane, CH4 plus oxygen gives carbon dioxide and water vapor, and a large amount of heat is produced. Here we are going to discuss the halogenation reaction, means the reaction of alkane with halogens, fluorine, chlorine, bromine. Here alkanes react with halogens by heating up to 400 degrees or in presence of ultraviolet rays in series of substitution reactions, and the product depends on the ratio between methane and the halogen in the reaction mixture. As the equation proceeds on the screen, my dear student, methane plus chlorine in the presence of ultraviolet rays, it substitutes one hydrogen atom by chlorine, forms methyl chloride or chloromethane, and releasing 1 mole of HCl. So, substitution reaction takes place for methane. My dear student, further reaction that chlorine reacts with methyl chloride or chloromethane in the presence of ultraviolet rays, forming dichloromethane or methylene chloride, and releasing also 1 mole of HCl. Further reaction here, my dear student, the chlorine reacts with methylene chloride or dichloromethane in the ultraviolet rays, forming trichloromethane or chloroform that has molecular formula CHCl3. And further reaction occur for the chloroform. Here it gives here another substitution by removing one hydrogen atom, gives carbon tetrachloride or tetrachloromethane. Now we are going to discuss the uses of halogenated derivatives of alkanes. The name and the formula and the use. Chloroform or trichloromethane, as structure formula shown on the screen. Here it's used as an anesthetic substance, but its use was stopped because the inaccurate dose here gives the patient death or causes death for the patient. Another example, halothane or 2-bromo-2-chloro-1,1,1-trifluoroethane, as the structure formula shown on the screen. It is an anesthetic substance, what it's used now as safe product for the anesthetic process. Another example here, 1,1,1-trichloroethane, as structure formula shown on the screen. Here it's used as dry cleaning agent. Here another example, ferrium, as shown on the screen, is most famous type. Here is dichloro-difluoromethane or tetrafluoromethane. Here is used in air condition and fridges, and rushed substance to liquid and perfumes, and the cleaner for electronic sets. And so, my dear student, we have give reason in this point. Ferriums are used in large quantities as cooling agent. The reason due to its cheap price, easily to be liquefied and non-poisonous and no corrosive for metals. And we have give reason for this point. There is an international agreement to prevent the use of ferrium is starting from 2020. Because ferriums cause the decay of the ozone layer, which protects the earth against the harmful effect of ultraviolet rays. Now, my dear student, we are going to discuss the thermal catalytic cracking. It is converting the heavy long petroleum chain to lighter short chain products. This process takes place during refining of petroleum oil to obtain gasoline for car fuel or ethene and propene in the manufacture of polymers. This process takes place by heating the heavy petroleum products under high temperature and pressure in the presence of catalyst. For example, the formula of C8H18, which is octane, by thermal catalytic cracking under high temperature and pressure, gives butene C4H8 and butane C4H10. Now we are going to discuss the economic importance of alkene. To obtain divided carbon, black carbon, which is used for painting polish and car tires. As the equation proceeds on the screen, methane, by heating at 1000 degrees in the absence of air, it gives the carbon and 2H2 gas is produced. To obtain water gas as fuel or reducing agent in matrix furnace, as we took in chapter 1. Here the reaction proceeds on the screen. CH4 plus H2O, which is water vapor or steam, at 725 degrees Celsius in presence of catalyst. It gives the mixture of two gases, carbon monoxide and hydrogen, which is water gas. Now we are going to discuss some questions. Choose the correct answer. The number of hydrogen atoms in an alkane having 4 carbon atoms is what? 5 or 10 or 14 or 12? My dear student, you have to apply the general molecular formula for alkane. Here we have to use the general formula CnH2n plus 2, so we can reach the answer here. It will be 10. Next point, the number of carbon atoms in alkane having 14 hydrogen atom is what? 14 or 7 or 6 or 5? If you think about it, yes, it will be 6. Next point, the molecular formula of an alkane having 12 hydrogen atom is what? C5H10, C5H12, C5H14, C5H8. If you think about it, yes, it will be C5H12. Next point, the number of sigma bonds between the carbon atoms and the hydrogen atom in an alkane having 3 carbon atoms is what? 4 or 6 or 10 or 8? If you write the structure formula, you will find it will be 8. The number of sigma bonds between carbon atoms in an alkane having 5 carbon atoms is what? 3 or 5 or 6 or 4? If you think about it, yes, it will be 4. Next point, the number of sigma bonds in an alkane having 4 carbon atoms is what? Is it 4, 8, 10, 13? If you think about it, it will be 13. Next point, alkanes are considered from what kind of hydrocarbons? Is it open chain saturated, unsaturated cyclic, or open chain unsaturated or saturated cyclic? If you think about it, yes, it will be open chain saturated. Next point, the molecular formula of alkane having 6 carbon atom is what? Is it C6H10, C6H14, C6H6? If you think about it, yes, it will be C6H14. Next point, the molecular formula of an alkane having 16 hydrogen atom is what? C8H16, C7H16, C6H16, C9H16. If you think about it, yes, it will be C7H16. Next point, the molecular formula of an alkane having 20 atom is what? C8H12 or C6H14 or C7H13 or C5H15. If you think about it, yes, it will be C6H14. Next point, compounds having molecular formula C3H8 is considered from what kind of hydrocarbon? Is it saturated aliphatic, or unsaturated aliphatic, or saturated cyclic, or aromatic. If you think about it, yes, it will be saturated aliphatic. Next point. In alkane, each compound exceeds than the previous by what kind of group? Is it methyl CH3, ethyl C2H5, methylene CH2, or ethyl CH3 CH2? If you think about it, it will be methylene group CH2 group. Next point. The number of methyl groups in 2-methyl 2-pentane is what? Is it 3, 2, 5, or 4? If you think about it, yes, it will be 3. Next point. The number of methylene groups in 2-methyl 2-pentane is what? If you draw the structural formula, my dear student, you will find the answer. 2 or 2 or 5 or 4. If you think about it, it will be 2. Next problem, my dear student. Examine the following reactions. NO in equilibrium gives half N2 and half O2 in gas state. And delta H is negative, means less than 1. Here, another equation, SO3 gas, it decomposes into SO2 gas and half O2 gas, moles. So, delta H in this reaction is positive, which means greater than 1. Here, my dear student, in which of these two equations do you expect, if the temperature is increased, leads to an increase in the extent of the composition or an increase in the equilibrium constant Kb of the reaction? Here, the solution of the problem. My dear student, in the reaction B, which the decomposition takes place according to Le Chatelier principle, if the reaction is endothermic, the increase in temperature here shifts the reaction in the forward direction. So the concentration of the products increase, so leads to an increase in the extent of the decomposition and increase the equilibrium constant Kb for this reaction. Next type of questions, write the scientific term. All ionized molecules are changed into ions, which happens in strong electrolytes. If you think about it, yes, it will be complete ionization. Next point, equilibrium arises in weak electrolyte between non-ionized molecules and their ions. If you think about it, yes, it will be in ionic equilibrium. Next point, at constant temperature, the degree of dissociation increases when the dilution increases. If you think about it, yes, it will be Ostwald law. Next point is a way for expressing the degree of acidity or alkalinity for aqueous solution. If you think about it, yes, it will be pH value. Next point is the resultant of multiplying the concentration of hydrogen ion times that of hydroxyl ion, and it equals 10 to power negative 14 mole per liter. If you think about it, yes, it will be ionic product of water. Next point, the negative logarithm of concentration of hydrogen ion. Yes, the answer it will be pH value. Next point, the multiplication of concentration of ions that are in equilibrium state with its saturated solution. If you think about it, yes, it will be solubility product. Next question, write an experiment to show the effect of temperature on equilibrium. First step, get a flask containing nitrogen dioxide gas which has a reddish brown color at room temperature, as the following animation will show. My dear student, we bring 3 test tubes that contain nitrogen dioxide gas and dinitrogen tetroxide at room temperature. Then we are going to put one of them in hot water and one of them in cold water. We find that the reaction that happens in cold water. As the reaction proceeds in forward direction, here the reaction gives dinitrogen tetroxide, which is colorless, while when putting it in hot water, the reaction proceeds in the backward direction, forming nitrogen dioxide gas, which is reddish brown color. So as shown on the screen now, here the effect of temperature is shown on the equilibrium of the reaction. So my dear student, as the equation proceeds on the screen, 2NO2, which is reddish brown color, on cooling it gives here dinitrogen tetroxide, which is colorless and releases heat, while on heating the reaction proceeds in the backward direction, giving nitrogen dioxide gas, which has reddish brown color. So my dear student, when the flask is cooled, it becomes colorless as the reaction shifts in the forward direction, forming the colorless N2O4. And as the equation proceeds on the screen, NO2 on cooling gives N2O4 dinitrogen tetroxide, which is colorless gas and releasing heat. And here, when the flask is in hot water, it becomes reddish brown color. And here, my dear student, as the reaction shifts in the backward direction, forming reddish brown gas of nitrogen dioxide gas. So my dear student, on heating the dinitrogen tetroxide, it forms nitrogen dioxide gas, which has reddish brown color. So the intensity of red brown color has increased. This reaction shows the effect of the changing of temperature on the equilibrium constant. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.